कैप हमने डब्बे में रख दिया था। स्क्रीन दिखाई दे रही है? आवाज आ रही है? ठीक। तो आज की क्लास में हमें क्या करना है, कंजर्वेशन ऑफ एंगुलर मोमेंटम पे एडवांस लेवल के क्वेश्चंस करने हैं, राइट? कि कैसे कंजर्वेशन ऑफ एंगुलर मोमेंटम काम करता है। अभी तक हमने काफी सारे आसान न्यूमेरिकल्स तो कर ही लिए हैं, है ना? Okay. Give me 1 minute. चलो शुरू करते हैं। क्वेश्चन नंबर 1 कह रहा है, rod of mass m and length L is hinged at its center. सेंटर पे हिंज्ड है, मास m है, लेंथ L है और हॉरिजॉन्टल सरफेस पे रखी है। The particle of mass m is moving with velocity v. It strikes the rod at end A and gets embedded. Okay. So find angular velocity with which system rotates about its center of mass after the bullet strikes the rod. Okay. बताओ बच्चों, क्या लगाओगे? हेलो, बोलो, कोई जवाब दो जल्दी से।
कंजर्वेशन मोमेंटम।
एंगुलर मोमेंटम, कंजर्वेशन ऑफ एंगुलर मोमेंटम लगाएंगे, लीनियर मोमेंटम नहीं, एंगुलर मोमेंटम। तो इनिशियल एंगुलर मोमेंटम हो जाएगा एम वी इंटू एल बाई टू, क्योंकि एक्सिस ऑफ रोटेशन से डिस्टेंस है एल बाई टू। रॉड इज गोइंग टू रोटेट अबाउट पॉइंट ओ, ठीक है। और टक्कर के बाद जो फाइनल एंगुलर मोमेंटम है वो है आई ओमेगा। अब आई किस किस का, एक तो रॉड का एम एल स्क्वायर बाई 12 प्लस पॉइंट मास का इंटू ओमेगा। सेम क्वेश्चन किया था कल इसी तरह का, एम एल स्क्वायर बाई 12 प्लस एम एल स्क्वायर बाई 4 इंटू ओमेगा। एम कॉमन निकाल के कैंसिल कर दो, सारा एम सेम है, एलसीएम आ जाएगा 12। तो यहाँ पे आ गया 3, आ गया 1, एल स्क्वायर ओमेगा, एक एल से एक एल काट दो, 6 आ गया। तो v इज इक्वल टू 4/6 एल ओमेगा, ओमेगा इज इक्वल टू 3v/12। समझ गया बच्चों?
यस।
ओके, फिर किसी को फिर से तो नहीं समझना कैसे किया? अगले सवाल के लिए तैयार हो?
यस सर।
ओके। क्वेश्चन 51 कह रहा है, consider a system consists of two identical balls. Each of mass capital M. Connected by a light rod. An impulse J is equal to mv. An impulse J is equal to mv is imparted to the system at one of its end. Okay, the angular velocity. Find angular velocity of system after impulse is imparted. ठीक है, तो ये हो गया तुम्हारा system. This is capital M, this is capital M. Rod is massless, बच्चों. Rod is massless and an impulse is provided this side, m into v. ठीक है, तो बताओ एंगुलर वेलोसिटी क्या होगी सिस्टम की. अब इसमें और हमारे लास्ट क्वेश्चन में क्या फर्क है? फर्क ये है कि पार्टिकल नहीं आया, कोई नया पार्टिकल नहीं आया, लेकिन स्टिल सम काइंड ऑफ इंपल्स इज इम्पार्टेड. ओके, देयर सम टाइप ऑफ इंपल्स इज इम्पार्टेड. एंड हाउ? आपने यहाँ पे मोमेंटम चेंज कर दिया, ठीक है, लेकिन अभी तुम्हें पता ही है हम क्या अप्लाई करने वाले हैं. हम कंजर्वेशन ऑफ एंगुलर मोमेंटम अप्लाई करने वाले हैं. बताओ कैसे करें? देयर इज न्यू एडिशनल मास.
Sir, impulse equal to change in momentum.
हाँ, impulse is equal to change in momentum. And how you can apply it here?
With the help of torque.
Initial
Here,
momentum is 0. Final momentum is 2 mv dash.
which gives you velocity of center of mass. But they want angular velocity of the system. To find angular velocity
And
of the
omega
system,
L by 2.
apply conservation of angular momentum. Okay, by conservation of angular momentum. So angular impulse is equal to change in angular momentum, right?
Yes, sir.
What angular impulse is applied about point O? What will be the
mv.
angular?
mv.
Wrong. mv into L by 2. This is angular impulse is equal to final angular momentum minus initial angular momentum. Initial angular momentum is 0 and final angular momentum is I omega. M V L by 2. Understood, everyone?
Yes,
or
sir.
no?
Yes, sir.
Now, you will not take moment of inertia of rod. No, because rod is light. Rod is massless. Here, moment of inertia of the system is because of point mass. So what is moment of inertia of this? M into L by 2 whole square, M into L by 2 whole square. You understand that? So moment of inertia of system is M into L by 2 whole square into 2 into omega. Now let's solve this. M will get cancelled. VL by 2 is equal to L square by 4 into 2 omega. 2, everything will get cancelled. 1 L will get cancelled. Your omega is V by L. Understood?
Yes, sir.
Okay, that's good. That's good. Please ask if you have any doubt, bacho. Do not hesitate to ask doubt, okay? If you have any doubt, please ask. This is one of the biggest chapter of class 11th, okay, with largest number of question in it. That's why हम चाह के भी तेज नहीं जा पा रहे हैं. ठीक है? Now see, next question says that a uniform rod of length 6a and mass 8 m lies on a smooth horizontal table. This rod is kept on a smooth horizontal table. Okay, this is center of the rod. Okay. Mass of rod is 8 m and its length is 6a. Okay, a two particle of mass 2m and m moving in the same horizontal plane with speed 2v and v respectively strike the rod at zone and stick to the rod. ठीक है बच्चों, एक 2m ऐसा आ रहा है, एक 2m ऐसा आ रहा है v स्पीड से, a दूरी पर है. ठीक है, ये 2a डिस्टेंस है और एक और पॉइंट मास आ रहा है 2e दूरी पर, पॉइंट मास m है और उसकी वेलोसिटी v है, ये दूरी a है. ठीक है, रॉड इज नॉट हिंज्ड. ओके, the velocity of center of mass and angular velocity about center of mass of rod just after collision. Find velocity of center of mass and angular velocity of system. After collision. बच्चों ये जो पॉइंट पास है ये रॉड में स्टिक हो जाएंगे कोलिजन के बाद, याद रखना. ओके, these point mass will get embedded into the rod. The time starts now.
Sir, omega is equals to v by 5a.
V upon 5a. And what is velocity of center of mass?
0.
Very good. Who is this? What is name of the student?
Anushka.
Sarah. Anushka. Very good, Anushka. Let me cross check the answer. 53. You are right, Anushka. Very good. Very good. Now let's see. Initial angular momentum is 0. No. For point mass, it is not 0. Initial angular momentum for point mass. For rod, it is 0. For point mass, it will be 2mv into a. Okay, but what is direction of this angular momentum, bacho? What is direction of this angular momentum? Direction of a is this. Direction of 2mv is this. Okay, so 2mv has minus j direction and r has minus I direction. So angular momentum is equal to r cross p, right? R cross j. So minus I cross minus j gives you plus k, right? Okay, understood everyone? How we got direction of angular momentum?
Yes, sir.
Plus, now angular momentum of the second point mass. Second point mass is going up and its r is like this. So it is plus j cap and plus I cap. So this time also k. This velocity is 2v, sorry. This velocity is 2v. M has velocity v and 2m has velocity v and m has velocity 2v. So momentum is again 2mva k cap. So what is the initial angular momentum? 4mva k cap. Okay. Okay, everyone.
Yes, sir.
Sir.
Okay. So now these point mass will get attached into the rod, so that the final angular momentum will be I omega only. Okay. Now what is moment of inertia of rod? 8m 6a ml square by 12. Agree? This is moment of inertia of rod. Any doubt? Bolo?
No, sir.
No, sir.
And what is moment of inertia of point mass? 2m into a square plus m into 2a square, right? Because one of the point mass is at a distance a from the O and another other point mass is at a distance 2a from the O. Agree? Into omega. ऐसे क्या अनुष्का?
Yes, sir.
ओके अब इसे इसको बराबर कर दो पहले इसको सॉल्व कर देते हैं 8m into 36 a square by 12 plus 2m a square plus 4m a square omega एक मिनट बच्चों तुम लोग सॉल्व करो मेरी पेंसिल डिस्चार्ज हो गई सॉल्व करो मैं 10 सेकंड में पेंसिल चार्ज कर लूं चलो करके देखते हैं इनटू ओमेगा यार ये काम क्यों नहीं कर रही हाँ इनटू ओमेगा सो दिस इज फाइनल एंगुलर मोमेंटम देखते हैं ये कितना आ रहा है 24
30 omega a square.
30 m a square ओमेगा राइट और जबकि इनिशियल कितना आ रहा है 4 कैसे आ रहा है भाई
सर
4
6
m
आएगा
कहाँ
सर 6 आएगा 2v है ना एक की वेलोसिटी.
अरे हाँ तो ये 4 आएगा 6 आएगा ये बच्चों 4 हो जाएगा ये 6 आएगा ये डिस्टेंस देखना 2a है और लीनियर मोमेंटम 2mv into 2a तो इट विल कम 4 ओके तो ओवरऑल 6 तो बराबर करते हैं अपन ये 4 नहीं आएगा ये 6 mv a है ना बच्चों is equal to 30
sir.
m a square omega so m got cancelled 1 a got cancelled this is 5 so omega is equal to v by 5a you got angular velocity omega and why linear velocity is 0 because we can apply conservation of linear momentum also because rod is kept on a smooth table now you check what is initial momentum for this particle it is minus 2mv because it is downward and for this particle plus 2mv because this is upward so initial linear momentum is 0 so final linear momentum is also 0 it means the system will perform only circular motion only rotational motion no translational motion because initial linear momentum is 0 so final linear momentum will also be 0 so there is no translatory motion only rotational motion okay understood ready for next
Yes, sir.
next question is very important a small mass m is attached to a massless string whose other end is fixed at P. As shown in figure. Okay. This is the question, bachcho. This is Z. This is moving with constant angular velocity omega. This is point P. Angular momentum about P is LP and angular momentum about O is LO. ठीक है, correct answers ढूंढना है. LO and LP do not vary with time. Second, LO varies with time, but LP remains constant. बहुत फेमस क्वेश्चन है, डेफिनेटली कहीं ना कहीं मिला होगा. चलो बताओ जल्दी. कौन
Third
निकल
option.
Sir, third option.
Yes, sir. Third.
वाह बेटा वाह. कैसे करा अभी ये बताओ. How solved? Suppose velocity is this. Suppose linear velocity is this. Okay. So linear momentum is also along velocity, and this is radial vector. This is radial vector. Okay. So how will you find direction of angular momentum? Rotate your finger from R to MB. So you will get angular momentum in this direction. You will get angular momentum in this direction, right? You understand that? Angular momentum at P. But suppose after some time particle reached here. Suppose after some time particle reached here. So this is R vector and MB vector is in this direction. Now rotate your finger from R to MB. The angular momentum will come in this direction. So the angular momentum about P is changing its value. But angular momentum about O is not changing its value. Okay, now let's take angular momentum about O. Let's take angular momentum about O. Make cross product of R and V. The direction will become up. The direction of LO is up. Now assume particle is here. Now again find direction of LO. Again it will come upward. Do you agree? Is it coming upward or not all the time? So angular
Yes.
momentum about O is constant, but angular momentum about P is varying. Okay, this is from IIT 2012. IIT Advanced 2012. Okay, very easy question. Understood?
Yes, sir.
Yes, sir.
Let's attempt more than one correct now.
Sir, can't we say that omega is changing with respect to
Omega is constant. Omega is constant. It is given in the question. Omega is constant with respect to O and P both. Omega is constant. Okay. V is changing. Omega is not changing. A disk of mass small m and radius capital R rotating with angular speed. पारस आया है? नहीं है. Is placed on rough surface. ठीक है, ऑप्शन 1 देखो अब, एल मतलब एंगुलर मोमेंटम, मोर देन वन करेक्ट। Initially, the force of friction on disk is mu mg right word. Okay, solve this question. बोलो भाई।
So first to fourth.
The angular momentum is comes out about point of contact, ठीक है, the frictional force is rightward initially, जब घुमा के जस्ट फेंका है, ठीक है, तो आगे ही नहीं जाएगी, वो आगे जाएगी फ्रिक्शन के कारण, तो ये फ्रिक्शन का तो मुझे आइडिया सही लग रहा है। बाकी एंगुलर मोमेंटम कंजर्वेशन का बाकी बच्चे ही सोच के बताओ भाई। अपार इज राइट और नॉट? व्हाट इज योर आंसर अपार? फर्स्ट एंड फोर्थ?
Yes, sir.
फर्स्ट एंड फोर्थ?
Second and fourth.
Yes, sir.
सेकंड एंड फोर्थ आर करेक्ट।
Yes, sir.
सेकंड एंड फोर्थ। क्या रे अपार, पॉइंट ऑफ कांटेक्ट में फ्रिक्शनल फोर्स लग रहा है, तो फ्रिक्शनल फोर्स के कारण टॉर्क आ गया ना। सी दिस, suppose you have already given some angular velocity to a disk, and now you are leaving this already rotating disk on the rough ground, so there will be a frictional force, right? You accepted that frictional force is there, I agree. तुमने खुद
Yes,
बोला
sir.
frictional force is there, that is mu mg. So this frictional force have a torque about O. Okay, so about O, frictional force will apply torque. Okay, संदल? संदल है भी कि नहीं? अनुष्का है, अनुजना है, अंकिता है, चिन्मयी है, टोटल 18 है। नूर है, सारा है, रोहित। रोहित समझ आ रहा है बच्चे? तो फ्रिक्शनल फोर्स विल अप्लाई
Yes,
torque,
sir.
so that angular momentum not conserved about O, because about point O there is a torque. Okay, but if you take point of contact, But if you take point of contact, there is no torque about point of contact. Why? Why there is no torque about point of contact?
Perpendicular
Because
distance 0 है.
correct. Frictional force is passing through point of contact. mg is passing through point of contact. Okay. So there is no torque. Rohit samjha?
Yes, sir.
About point of contact. So angular momentum is conserved about. Come on, tell me angular momentum
Point of
Point of
contact.
contact.
Point of contact.
conserved about point of contact. लास्ट ईयर कराया था क्या ये क्वेश्चन मैंने? समझ आ गया? बनने लगा?
Yes,
फुल
sir.
कॉन्फिडेंट?
Yes, sir.
गुड.
सर सर ये समझ में नहीं आया, फ्रिक्शनल फोर्स राइट वर्ड क्यों लगेगा?
तुम एक डिस्क को पहले ऐसे घुमाओ, इस डिस्क को पहले घुमाओ, घुमाया,
यस सर.
अब जमीन पे छोड़ो, अब जमीन पे छोड़ दो. तो बताओ, छोड़ दिया जमीन पे?
यस सर.
तो इसका पॉइंट ऑफ कांटेक्ट कहां जाना चाह रहा?
पीछे.
तो फ्रिक्शन कहां लगेगा?
यस सर.
अब एक कितना रोटेशन करा था तुमने 11th में? यू फॉरगॉट एवरीथिंग. नूर अंडरस्टूड बता?
Yes, sir.
Okay. Next question is a disk of mass m and radius capital R. कंसेप्ट स्ट्रांग हो रहे हैं?
Yes, sir.
Smooth horizontal table. A particle of same mass m collides with stationary disk and get embedded into it as shown. Then डायग्राम बना देता हूं. It's time for diagram. This is a disk of radius r and mass m kept on a horizontal table. This is going with velocity v naught. Okay, ये बिल्कुल उसकी एज से टकराएगा और चिपक जाएगा. Okay, so option 1 says angular momentum of disk plus particle, angular momentum of disk plus particle system can be conserved. More than one character can be conserved only about center of disk. The speed of center of mass is V naught by 2 after collision. Right. Third point is the angular speed after collision is V naught by 2r about center of mass of disk plus particle system. The kinetic energy of system is conserved during collision. चलो बताओ कैसे करना है. More than one correct है. बोलो भाई कैसे करना है. This is your complete question on screen. प्रितपाल एक आध सवाल का जवाब भी दे दिया कर बेटा, आ जाता है बस. आता ना जाता भारत माता जैसे.
So first, second or third.
Sir, 2 and 3.
अनुष्का ना.
Yes, sir. Yes. Same as Anushka.
मैं तो अनुष्का के साथ जाऊंगा भाई. अनुष्का और सारा के साथ जाऊंगा.
Sir, मैं भी अनुष्का के साथ.
अपार
सर मैंने
सोच लो.
यूट्यूब में कर दिया था.
अपार सोच लो.
सर अब क्या सोचना है, एक बार होता है तो हो गया.
कैसे गलत करता रे. एंगुलर मोमेंटम हर पॉइंट के अबाउट कंजर्व्ड है. एंगुलर मोमेंटम इज कंजर्व्ड अबाउट एवरी पॉइंट. वी टेक कंजर्वेशन ऑफ एंगुलर मोमेंटम about O so that it will be easy for us for calculation. Okay. समझ आया.
हाँ सर.
इतनी बड़ी बड़ी गलती करोगे तो फिर इतना सारा एंगुलर मोमेंटम कंजर्वेशन समझा कैसे काम चलेगा रे. चलो अब अगले सवाल के लिए तैयार हो जाओ. Give me a minute. चलो अब लिखो क्वेश्चंस बेस्ड ऑन टॉपलिंग. लिख दो क्वेश्चंस बेस्ड ऑन टॉपलिंग. टॉपलिंग इज अ वेरी इजी concept. टॉपलिंग क्या होता है. ऑब्जेक्ट ना किसी एक पॉइंट के अबाउट घूम जाता है. उस पॉइंट के अबाउट, जिस पॉइंट के अबाउट ऑब्जेक्ट के घूमने की संभावना है, उस पॉइंट के अबाउट नेट टॉर्क 0 कर दो तो तुम्हें टॉपलिंग का रिजल्ट मिल जाएगा. ठीक है, फॉर एग्जाम्पल हम शुरू एक बहुत ही आसान सवाल के साथ शुरू करते हैं. A cubical block of height A and width B is placed on horizontal surface with sufficient friction. Okay. For a given force, let me make diagram also first so that you can start thinking. This distance is A, this distance is B, and the given force applied at this point. Sufficient friction is available. Okay. So option 1 is probability of toppling is more if B is greater than A. Probability of toppling is more if A is greater than B. Probability of toppling is more if A is equal to B. Fourth कहता है block will not topple at all. बताओ भाई क्या सोचना है? प्रितपाल,
Third option.
only single correct.
Sir, second option.
Sir,
A is
second
greater than.
Read question again. Only 1 or 2 students giving answer. देखो, for some student toppling is something very new. They have never seen, they don't know anything about toppling, some students. Okay. So imagine if this box gets toppled, means ये घूम जाए, आगे खिसकने की जगह नूर इमेजिन कर घूम जाए. ठीक है चिन्मयी?
Yes, sir.
Instead of slipping forward, it will
Yes,
start
sir.
rotating. So about this point it will topple. Understood?
Yes,
So
sir.
imagine a yellow color. Can you see a yellow color? Very small stopper type something. So if box
Yes, sir.
will topple, it will topple about this point. Okay. Now our task is to find net torque about this point. If net torque about this point is 0, then box will not topple. Okay. But if clockwise torque is more than anti-clockwise torque, then it will topple. Okay. So this is external force, you can see, and a frictional force is acting at this point at the backward direction. Am I right?
Yes, sir.
What do you say, student? Is the frictional force is acting in this direction? Am I right?
Yes, sir.
What
Yes,
is
sir.
frictional
Yes,
force?
sir.
Mu
Yes,
mg.
sir.
One more force we must represent. Tell me what? Tell me one more force.
Normal reaction.
Mg. One more force, mg, which will always act at the center.
Downward.
And where is
Downward.
normal reaction? Apart.
reaction.
Sir, right
कहाँ?
corner पे. Right
अरे
corner.
वाह, अरे वाह, जीत दिया तू. Apart तू जीत गया. The most important force is normal reaction. And imagine block is about to topple, and then block is about to topple. Normal reaction will shift itself at this point. You understand that? Normal reaction is not opposite of mg. Sorry, normal reaction will get shifted. Why normal reaction will get shifted? Imagine this situation of the block. Give me 1 minute. Imagine this situation of the block. This. नहीं यार ये तो साथ में घूम रहा है. Okay, I'll make a new diagram. Imagine this situation of the block, बच्चों. When block is about to topple, where normal reaction will come?
At the corner.
At the corner. So always remember, in case of toppling, normal reaction will shift at a point from where block is going to topple. Okay, normal reaction will shift at the toppling point. Always remember. Now, can you help me writing torque about this point, toppling point? Suppose this point is A. Okay, block will not topple if net torque about toppling point is 0, right? So can you help me in that? What is torque of capital F about A? What is torque of capital F about A? Torque due to
F cross A.
capital F about
A
point A
cross F.
is F into A, and it is clockwise, right? Right,
Yes,
Ankita?
sir.
And
Yes, sir.
what is torque of mg about A?
mg b by 2.
Due to mg about A is equal to mg b by 2, and this is anti-clockwise. Am I right?
Yes, sir.
And torque due to frictional force and normal reaction is 0 because these two both the forces are starting from the same point, right?
Yes, sir.
Torque due to normal reaction and friction. Pritpal, are you sleeping?
नहीं सर.
समझ आया? For no toppling. For toppling, okay, condition for toppling. What is condition for toppling, बच्चों?
Net torque must be 0.
नहीं
Torque of
condition
friction.
for toppling. For
Torque of
toppling,
friction must
The
be
torque must be
greater than mg.
clockwise torque must be greater than anti-clockwise torque. So F into B must be greater than mg A by 2. Understood? Understood?
Yes,
Yes.
sir.
Okay, so tell me when condition of toppling, when toppling is easy. Now what you choose?
When A is
The condition we got is,
A
where
must
are
be greater
options?
than B.
The condition we got, FB should be greater than mga by 2. Okay, so option A or B, which one you will choose? One student already taken B, right? One student who has taken B already. किसने B ले लिया already? He is right. He is right. See, the toppling is easy if less force is required. The A by 2B. Okay. तो इसको और कंडीशन में कैसे बताएं बच्चों? F लेते ना? Okay. How you concluded that? Why option B is correct from this equation? Can you tell me? Can anyone tell me?
Sir, FA.
Oh, FA into mg by 2. इतनी देर से क्यों नहीं बोल रहे? वही मैं सोचूं गलत क्यों आ रहा है? इतनी देर से क्यों नहीं बोला बच्चों? FA should be greater than MGB by 2. Okay. So F should be greater than MGB upon 2A. Okay. So it will be easy. You need less force. If A is greater, A is big, you need less force of, you need less value of capital F. Okay. Understood now? Agree? अगर A बड़ा
Yes,
है
sir.
तो कम force required है. Agree? चलो अब मैं नेक्स्ट
सर
क्वेश्चन करता
अगर
हूँ. हाँ
टॉपलिंग फोर्स के ऑपोजिट साइड में होगा तो भी यही इक्वेशन लगेगा.
हाँ तो फिर आप फोर्स, you need to apply force from other side then,
ओके.
है ना? तो कंडीशन बदलोगे, you will be able to solve. No problem at all. Okay. टॉपलिंग के और क्वेश्चन थे, पता नहीं कहाँ गए बेटा. Now can you handle questions related to toppling बच्चों? I will search and I'll give you more questions later. Okay, let's solve one more question based on toppling. I think this question required concept of toppling. A uniform solid cylinder having height L and diameter D placed on rough surface. So this is a cylinder of height L and diameter D is kept on a rough surface. Kept on the rough surface. Okay, now this rough surface is moving forward with some acceleration. Okay, this rough surface is moving forward with acceleration. Okay. Now find maximum value of acceleration for which cylinder remain in equilibrium. Find maximum value of acceleration for which cylinder remain in equilibrium. Okay बच्चों, that's it for the day. क्लास का टाइम हो गया है. I have next class now. मिलते हैं अगली क्लास में. Solve this question. Give me, you can send me answer.